Good morning, all of you, and welcome to the course Organic Chemistry 4, offered by St. Albert's College, Autonomous, Ernakulam, through its e-learning platform. Myself, I am Dr. Krishnakumar KS, Assistant Professor in Chemistry of St. Albert's College. As I have already mentioned in the introductory video, the course contains 3 units, namely nitrogen-containing compounds, heterocyclic compounds, and active methylene compounds. In this lecture, I am going to start with Unit 1, that is nitrogen-containing compounds, and I am going to begin with nitroalkanes. I would like to use 2 parts of video because I don't prefer to have a long video because most of us may have video buffering issues if I use a long video. I hope that this is okay for you. In first part of video, I will give a short introduction on nitro compounds such as structure, preparation, and an important part, tautomerism. Okay? So we will start with our compound nitroalkanes. We know that nitroalkanes are nitro derivatives of alkanes. Their general formula is RNO2, where R is the alkyl group. These are the basic things that we know. And when we come to the structure, it is very clear that nitroalkanes can be represented by the resonance hybrid of these two canonical structures. We know that how to draw the resonance structures. For example, this is one canonical structure and the electrons, they move to here to form a double bond here. So when the double bond comes here, this double bond will not stay here. These electrons will move to oxygen. You should draw the arrow mark like this. So it becomes O minus. This becomes a double bond here and this becomes a single bond here and O minus. So these are the two resonating structures of nitroalkane. And this is quite evident from the fact that the two NO bonds in nitroalkanes are equivalent. They are having a bond length of 122 picometer. So this is a proof for the existence of resonance between these two structures. Another important point regarding nitroalkane, that nitroalkanes are isomeric to alkyl nitrides. When a general formula RNO2 is given, we should not be confused with alkyl nitrides and nitroalkane. That means in nitroalkanes, NO2 group is attached to carbon through nitrogen atom. You see the connection is between the carbon and nitrogen, the carbon of R group. Then in alkyl nitrides, the connection is between carbon and oxygen. So even though they are having the same molecular formula, structurally they are different. That's why they are isomeric. So nitroalkanes are isomeric to alkyl nitrides. And we can easily distinguish between these two, nitroalkanes and alkyl nitrides. Nitroalkanes on reduction means addition of hydrogen. Nitroalkanes, they give amines, while alkyl nitrides on reduction they give alcohol. And it's very clear from here. See, when hydrogens are added here, since nitrogen is attached to carbon, it should be RNH2. I mean, if hydrogen is added here, oxygen is connected to R group here, carbon here. So the product must be ROH. So nitroalkanes on reduction, you get amine, while alkyl nitrides on reduction, you get alcohol. When we go to the nomenclature, nomenclature of nitroalkanes is very simple one in our hands. Nitro compounds are named by writing the word nitro before the name of the parent compound. For example, there is a methyl group and then it is nitromethane. This is an ethyl part, so nitroethane. Here the nitro group is on propyl part, so it's 1 nitropropane because the nitro group is in the first carbon atom. When the nitro group is on the second carbon atom, this is 2 nitropropane. Now classification. When we come to classification, this classification is based on the alkyl part attached to the nitro group. We can classify them as primary nitroalkanes. That is, the nitro group is attached to a primary carbon atom. Example, RCH2NO2. Here, NO2 is connected to a primary carbon atom. Secondary nitroalkanes, the nitro group is attached to a secondary carbon atom. Here, this is a secondary carbon atom. Tertiary nitroalkanes, the nitro group is attached to a tertiary carbon atom. Here, it is a tertiary carbon atom. So, nitroalkanes can be classified into primary nitroalkanes, secondary nitroalkanes, and tertiary nitroalkanes based on the alkyl part attached to the nitro group. Now we will quickly go through the preparative methods, the preparation of nitroalkanes. The first method which I am going to show is from alkyl halides. When alkyl halide is heated with ethanolic solution of silver nitride, this is silver nitride, nitroalkane along with alkyl nitride is formed. Oh, this equation is not balanced, sorry. We can put 2 here, maybe we can put 2 here and we can put 2 here. So now it's balanced. Okay. So first preparative method is from alkyl halides. When alkyl halides are treated with silver nitride, a nitroalkane along with alkyl nitride is formed. Okay. So the next one, liquid phase nitration. So hydrocarbons are heated with a concentrated HNO3 under high temperature, under high pressure, you get nitroalkanes. This direct nitration of alkane is very difficult one compared to that of arenes. We know that. Hence, it is not a very good laboratory method, but maybe of commercial importance in the bulk production of small nitroalkanes. And this is liquid phase nitration. We can also perform vapor phase nitration also, in which this reaction is carried out in the vapor state by heating the alkane with nitric acid and at a high temperature 700 Kelvin or something like that. Okay. Now, third method, from tertiary alkyl amines. Tertiary alkyl amines, on oxidation with KMnO4, you get this tertiary alkyl nitro group, nitro compound, you see. So in this reaction, the amine must be primary. This amine is primary, you see. The amine is primary, it's NH2 group. But the alkyl part is tertiary. So this is the third method. From tertiary alkyl amines, we can oxidize tertiary alkyl amines to form a tertiary alkyl nitro compound. And when we come to tautomerism, we know that what are tautomers or tautomerism. Tautomers are isomers of compound which differ only in the position of protons and electrons. There is no change in the carbon skeleton of the compound. So any chemical change which involves simple proton transfer in an intramolecular fashion, that is called tautomerism. We will take this nitro compound as an example. And I wrote primary and secondary nitroalkanes show tautomerism. What does it mean? You see here CH2, it's a primary nitroalkane. One proton from this CH2 group goes. That means the electron pair comes between this C and N. So this bond becomes a double bond. You see, this bond became a double bond. So this double bond will not stay here. It will go here so that it becomes O minus. So that O minus receives that H plus. So it becomes OH. So there is only a redistribution of proton or electron. There is no change. There is no change in the carbon skeleton. So we can say that this compound, this structure and this structure, they are tautomers. And this structure which has N double bond or O minus form is there. It is known as nitro form. And this structure is known as acid form. So simply I can say that nitroalkanes exhibit tautomerism. They exist as tautomers, two tautomers, which are nitroform and acetiform. And I say that the nitroform is always stable. We have seen this one before. Nitroform is very stable because of the existence of two resonating structures. So the equilibrium is always shifted to left. This equilibrium is always shifted to left due to the relative stabilization of the nitroform. Of these two forms, nitroform is more stable, so the equilibrium is shifted towards left. So, as a nutshell, I say that nitroalkanes exhibit tautomerism. They exist as two tautomers, nitroform and acetiform, and the equilibrium is shifted towards the nitroform because the nitroform is resonance stabilized. Thank you very much for listening this video, and remember, lecture 1 is not completed. In the next part, I will discuss about some important reactions of nitro compounds. So see you in the next video. Thank you.